Alrighty, so we're going to start 6.3 today. We're kind of going to bounce between two activities, do parts of both. But to start, we're going to start with this one. Is it smart to foul at the end of the game? So, in 2005 Conference USA basketball tournament, Memphis trailed Louisville by 2 points. At the buzzer, Memphis Darius Washington attempted a three-pointer. He missed but was fouled and went to the line for 3 free throws. Each made free throw is worth 1 point. Was it smart to foul? So first, we're going to start by just trying to talk about the options here. So this person's going to attempt 3 free throws, um, and hopefully make up those points. So we're going to use I'm going to use G for a make and B for a miss. Or kind of like good and bad, just so we're not writing the same letter over and over and over. So we're going to come up with all the possible ways. So if you want to take a minute to pause, let's try and come up with them. All right, but we should get he makes all three. He could make the first two and miss the second or the last one. Make the first, miss. Make, miss, miss. Or he could miss, 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 make. Or miss, make, miss, make. Okay, these are the 8 options. All right, the only 8 options. Okay, let's classify them for ways. What would happen in the game? So, in order to win, needs all 3. It's the only way, right? You're down 2. If you score 1, you're down 1. Then you score again. Then you score your third one. All right. To lose, you lose if you make 0, right? Or if you make just 1. So 1 good, 1 good, 1 good. And then it's overtime if you make 2 of the 3. So 1, 2, 1, 2, 1, 2. Okay. Let's calculate the probability of each. Whoops. So the probability of the win would be, well, we know that Darius is a 52% free throw shooter. Find the probability that they will win, lose, or go to tie. So, for example, you only win, right, if you're here. So that means that they made the first one. Sorry, let's do this actually. You win if it's the probability of a win is equal to a good and a good and a good. Now, the question is, are these shots independent? I would say yes. You could say that there's some nerves at play, right? Like if you make or miss the first one, what happens from there? But in terms of like, does making the first one not actually impact it? If you truly are just a 72% free throw shooter, the answer should be that they are independent. So since they're independent, we can just multiply these together. So 0.72 times 0.72 times 0.72. 0.72 to the third power. 0.373. Now, I'm going to transition over to overtime. So overtime was in these situations where, again, you made 2 and missed 1. So that means, again, these are independent, but I need to make 1, a second one, and I need to miss the last one. So if a make is 0.72, that means a miss happens 0.28. So this equals 0.145. Now, the thing is, though, is this is just one way, right? That's a make, and then a miss. However, he could have made, miss, made, or he could have missed, made, and made. So there's actually 3 ways for this to happen. So we need to take this probability and multiply it by each way. So 3 times that. So it's 0.435. Okay. Now for the losses. There's 2 ways to lose. They could have missed all of them, right? So that would be 0.28 times 0.28 times 0.28. There's only one way for that to happen. You miss, you miss, you miss. So we could just do 0.28 times 0.28 times 0.28, 0.022. Okay, so it's that way. That's if you miss all of them. Or you miss 2 of the 3. So that means you go 0.28, 0.28, but you make the last one 0.72. All right. But again, there's 3 ways for this to happen. So I need to take that probability and times it by 3. So 0.28 times 0.2 times 0.72. Take that, times it by 3. I get out my probability, 0.169. All right. So if I add all those up, 0.373 plus 0.02, .99, so a little just under rounding, but that is why. If we didn't include these extra 3 ways, we would have been substantially under the number. So that is why you have to multiply it by 3. All right. We're not going to go through the rest of this activity, but what I wanted you to do, or the purpose of this activity, is this whole section 6.3 is all about binomial distributions. Okay, and the activity just above simulates a binomial activity, or sorry, a binomial distribution. We have another adjective or another acronym to help us out here. It is called BINS. All right. So B stands for binary. Binary means there's 2 options: a success and a failure. So for this activity, success was a make versus a miss. And that's the first one. The next one is I, which stands for independent. We need the trials to be independent. Okay. The N stands for the number of trials is fixed and known. So in this case, 3 free throws. We knew how many times they were going to take a free throw. And the last one, S, stands for same probability. Okay, we need each opportunity or each trial to have the same chance of happening. That links kind of with the independence. A little bit different, but partially there as well. Because if the probabilities start changing, then they're no longer going to be independent. So we need both of those. So this is our acronym that we use called BINS to determine if something's binary or not. Just seeing if you want to write down anything else. Okay. You could basically put this thing that we just wrote down in our next box on the next page if you want to. Or if you found some space, that's fine. But the last thing is binomial, how to calculate it. So here is the formula for it. You can see it down here. If it's a binomial distribution, then the probability that x equals k is equal to n choose k probability to the k 1 minus probability to the n minus k. And we'll talk about what that means here in a second. Just want to make sure I had everything down correctly. Cool. Okay. So how to interpret this first? This is the number of successes equals k, whatever the number is. Okay. Our n down here, this is the number of attempts. So in the problem we just did, our number would have been 3 because that's how many attempts we had. All right. It also comes from the n in bins. Okay. This k is the number of successes. And it is right here as well. So for example, if I wanted to win that game, I needed 3 successes. If I wanted to go to overtime, I needed 2 successes. P, that is just the probability of success. Okay. And I raise it to the k power. All right, again, same thing, the number of successes, because I want I want this to be, there should be that many successes, so I need to multiply it by that many times. And then however many successes there are not, that would be the number of failures. So this 1 minus p is equal to the probability of failure. And then this is the number of failures. Right, so if I had 2 successes, that means my k would be 2 and my failures would be 1. We'll use this for, I'll show you this form in action here. Let's say we want to find, let's do that, of 2 made free throws. So the probability that x equals 2, that is equal to n, which is 3, choose 2, times the probability of success, which is 0.72, to the second, times 1 minus 0.72, to the 3 minus second. So we can clean this up a little bit. We'll keep this 3 choose 2 for a second, but this is just 0.72 squared, and then 0.28 to the first. And notice for 2 made free throws, 2 made free throws is down in this section, 0.72, 0.72, 0.28, and then times by 3. So this is really 0.72 times 0.72 times 0.28. And then that means that this number should hopefully get us out 3. So to check, go to calculator, math, over to probability, and we have n choose r. The variables are a little bit different, but it's in the same format. So my n is 3, my r is 2. Press enter, boom, I do get 3 out. All right. So this whole thing is my binomial equation. All right. This number here tells you the number of ways it happens. is called the binomial coefficient. All right. So there's that. And so that's just kind of the start of the binomial situation. All right. So let's flip over to this pop quiz. We're going to do a little bit more specific with the binomial and using our calculator to calculate these things. So it says it's time for a pop quiz. We hope you're all ready. The quiz consists of 5 multiple choice questions. Each question has 4 answer choices labeled A through D. Now for the bad news. You will not get to see the questions. You just have to guess. So right now, take a moment and guess what your answers would be for this test. So you can randomly fill them in. Boom. Okay. We're going to use a random number generator to help us out here. Math. Probability. Random int. So this is a good review of 6.1. I'm going to run a simulation here to kind of simulate this, what the correct answers would have been. So I need numbers between 1 and 4. And I could pick 5 of them because there's 5 out. I'm going to do this for 5 times. And I do want repeats. Boom, paste. So on here, the correct answer would have been 34112. So 3, 4, 1, 1, 2. So I only got 1 correct. Hopefully you are a better guesser than me. All right. But let's talk about it. So if we let x be the number of correct guesses, would this be a binomial setting? So when are they asking that? They're asking you to check for bins. So let's check. So B, binary. Yes, it's either correct or wrong, correct or incorrect. So only 2 options. So it's binary. Binary. Independent. Yes. Knowing the answer to 1 didn't change anything about the other one. It's not like it said there had to be even number of options picked or anything like that. So they're definitely independent. And number of trials. Yeah, that was fixed and we knew it was 5 trials. All right, and then S is same probability. Okay, and again, so in this case, yes, the probability of, and it's always of the success or whatever x is. So x is the number of correct. So the probability of a correct guess, 0.25 here, because there's 4 options. All right. So let's calculate the way to get the 2 answers correct. That would be the probability that x equals 2. So that is 5 choose 2 times 0.25 to the second times 0.75 to the third. 5 math choose. Times 0.25 to the second times 0.75 to the third. So this comes out to 0.264. Now, kind of a lot of work. So your calculator will actually do this for you. And so it's in, let's see, I think it's in second distribution. It is. Okay. So if you go second distributions, it'll pull it for you. We're going to go up because it's at the very bottom. We're in a binomial setting. Okay. And so this is the one time we'll probably use a PDF. All right. So I see it like cursors on A. You can put this in your calculator if we do binomial. Okay, when I click on it, it gives me these options. The options are trials, which is my n. So trials equals 5, comma, the probability of success is 0.25, comma, the number of successes. So 5.25 and 2. Boom, and answer out, and I get out that correct answer. Okay. So PDF is for one specific value, versus CDF is a continuation. It needs a lower bound and an upper bound. PDF just needs one value right there. All right. So I can do this again and again. If you don't have the calculator where it gives you the commands, you would put it in just like this: binomial PDF, number of successes, comma, failure, comma. Or so that's trials, probability, and then successes. So if I want to fill out this chart, boom, 0.237. 0.396, 0.0888, 0.015. And lastly, you can start to see just by purely guessing, it is very difficult to get these all of them correct. So 0.000977. All right. Kind of took a little while. There's a faster way, especially if you want to try and find the mean of the distribution here. So what I can actually do is I'm going to go into my list. I'm going to clear them. Normally we want our L1 to be our x's, so 0 to 5. And then L2, I want my probability. So I can actually get these really easy. Go up, press enter, and now I want to get my geometric PDF. 5, boom, boom. And now I don't want my x value. I want to get my x value from up here, which are in L1. If I paste, this will now take a binomial PDF of 5.25 and then the x value there. If I press enter, there it is. And I know it's hard to see, but they're all equal. All right. And the reason why this is really nice is because I can go boom, stat, calc, 1 var stat, L1, L2. Boom. My mean equal to 1.25. And that also means that, hey, my sigma of x is equal to 0.968. And so interpreting this is just the average answer. The average number of answers correct would be 1.25, and then the typical distance a data point is away from the mean is 0.968. And this is where we'll hold off for today. We'll kind of wrap up and make some shorthands of some of this tomorrow.